Alrighty, okay, we'll get started here. Good afternoon, everybody. My name is Nada Filipovic, and I am the marketing manager at American Wire Group. We'd like to thank everybody for joining us as we present PV wire and cable today. So I'm just going to go through a few housekeeping items here. So the webinar is being recorded. A copy of the recording will be emailed to all attendees next week. Anytime during this webinar, you can ask questions by entering your request in the chat box and then selecting send question to staff. We'll answer all our questions time permitting. If we're unable to get to your question today, we will answer by email afterwards. So now I'll pass it over to Isaac Muller, our application engineer at American Wire Group. Take it away, Isaac.
Thank you, Nada. Okay, so let's get started here. So I'm Isaac Muller, applications engineer for American Wire Group. For more than 11 years now, I've been working as an applications engineer for a wire and cable manufacturer, focusing on wire and cable applications in the United States and Canada. Currently, I'm a voting member on the Canadian Electrical Code Executive Committee and Part 1, representing wire and cable manufacturers. I am Section 4 Chair for Conductors and Ampasties, and Section 12 Vice Chair for Wiring Methods. I continue to be active in these positions on the Canadian Electrical Code Committees. I am also a member of several task groups and working groups for the Canadian Electrical Code. Over the past decade, I've been actively participating on UL and CSA standards committees, focused on how wire and cable is manufactured, tested, and marked. Although I have been focusing on manufacturing, I also have practical experience in determining the right wire or cable for many different applications, with a focus on NEC or Canadian Electrical Code compliance. As a professional electrical engineer working for a wire and cable manufacturer, my primary role has been to run several different calculations for ampacity, conductor operating temperature, impedance, sag and tension, and other factors, often using software such as SimCap or SAG10. Having been working in the wire and cable industry for over a decade, I've built a strong network of technical professional contacts. Rest assured that if you have a wire and cable related question, I either know the answer or can find someone who does. For nearly 20 years that American Wire Group has been operating, thinking customer has been at the heart of our core values. Our core values shown here are what our team practices daily. We believe this is what makes us the strong company that we are today. Our continually growing range of wire and cable products emphasize our focus on servicing our customers' needs. We have overhead conductors such as ACSR, AAC, and ACSS, along with OPGW, bare copper, as well as copper or aluminum clad steel to cover your overhead transmission and distribution system needs. Our medium voltage power cables are rated 5 kV to 46 kV with fully water blocked stranded conductors meeting or exceeding ICEA requirements. We use only the highest grade EPR and TRXLPE insulation compounds for a worry-free medium voltage cable system. Although our focus is on concentric neutral or round wire metallic shields, we also have flat copper tape or flat copper strap metallic shields available should your need for these systems arise. With a 90 degrees Celsius or 105 degrees Celsius continuous conductor operating temperature range and an available cross-link polyethylene jacket system, you are guaranteed to get a medium voltage power cable that meets the needs of today's demanding installations. We also carry a wide range of low voltage cable systems, including substation cables, DLO, as well as battery storage system wire and cable. The cables that we offer are listed, certified, or qualified in accordance with UL, CSA, ICEA, or ASTM standards, making them suitable for installation and use in the United States or Canada. During this presentation, we will take a closer look at photovoltaic cable and why you should choose American Wire Group as your preferred source for these cables. We will briefly look at what the UL and CSA standards allow for photovoltaic cable constructions for installations in the United States and Canada. You will see that although there are many options available, there are only a few key constructions that are commonly used. We will look at the typical applications for these cables, indicating where you can find relevant ampacity information in both the NEC and the Canadian Electrical Code. Whether your installation is in the United States or Canada, we are here to support you. We will address field testing concerns, focusing on the industry accepted practice of insulation resistance testing following National Electrical Testing Association, or NETA, guidelines, and our recommendations. Insulation resistance testing is also known as Mager testing. We will finish this presentation off with a summary, followed by an opportunity to ask any questions that you may have related to photovoltaic wire and cable. Photovoltaic cable, or PV cable, is typically a single insulated conductor used to interconnect the solar panels or solar modules together, forming the DC portion of the circuit. Since these cables are continually exposed to sunlight, they must be sunlight resistant and marked as such. We will see more on this later. PV cable is designed for use in the DC circuit of grounded and ungrounded systems, rated up to 2 kV DC. These cables are generally installed in free air, raceway or conduit, or direct buried applications. Installation requirements are covered in the NEC Article 690 for the United States and Canadian Electrical Code Section 64 for Canada, specifically Rule 64-200. PV systems range in size from a few kilowatts up to hundreds of megawatts. Larger PV systems are generally ground-mounted systems. Ever since January 2013, American Wire Group has sold over 87 million feet of PV cable in North America. You can be confident that American Wire Group knows PV cable. We have experience that you can trust. There are two key standards for PV cable. First one being UL 4703, and the next being CSA C22.2 number 271. UL 4703 covers PV cable for installation and use in the United States under the NEC. Although the first published edition of the standard was released in 2014, the outline of investigation for photovoltaic wire was released in 2005. The latest edition of the standard was published not more than a year ago. CSA C22.2 number 271 covers PV cable for installation and use in Canada under the Canadian Electrical Code. This standard was created in response to Canadian market demand for PV cable, as there were many feed-in tariff programs to help subsidize PV installations. The first publication of this standard was in 2011. The latest edition of the standard was published just over a year ago. Both standards are evolving with the industry, making sure that there is a solution for any PV system in the United States and Canada. Both standards recognize inline spark testing as the method of determining insulation integrity during manufacture. However, we also perform periodic insulation resistance testing in water. This is done to make sure that our PV cable will not just meet, but will exceed the field testing requirements prescribed by the industry-accepted NETA specifications for insulation resistance testing in the field. Our PV cable is also designed to meet or exceed applicable ICEA standards for cables rated up to 2 kV. UL 4703 allows for a wide range of PV cable constructions. Both single and multi-conductor assemblies are allowed, rated 600 volts, 1000 volts, or 2000 volts. A wide range of temperature ratings are allowed from 90 to 150 degrees Celsius for dry applications, maintaining a 90 degrees Celsius wet rating. Conductor material can be copper, aluminum, or copper-clad aluminum, ranging in size from 18 gauge for copper or 12 gauge for aluminum or copper-clad aluminum, up to 2000 kc mil. A wide range of insulation compounds are allowed, including both thermoplastic and thermoset compounds with an optional jacket. Sunlight resistance is of course mandatory since these cables will be continuously exposed to direct sunlight. Flame spread markings are optional, along with the cold bend and cold impact markings and the direct burial marking. As you can see, a wide range of cables are possible. CSA C22.2 number 271 allows for an equally wide range of PV cable constructions. Both single and multiple conductor assemblies are allowed, rated 600 volts, 1000 volts, or 2000 volts, where 600 volt rating is only allowed on RPV cable constructions. A wide range of temperature ratings are allowed from 90 to 150 degrees Celsius for dry applications, maintaining a 90 degrees Celsius wet rating. Conductor material can only be copper or aluminum, ranging in size from 14 gauge for copper or 12 gauge for aluminum up to 2000 kc mil. The Canadian Electrical Code does not currently recognize copper-clad aluminum conductors for installation and use in Canada. A wide range of insulation compounds are allowed, but limited to thermoset compounds. Thermoplastic insulation systems are not recognized for installation and use with DC circuits in Canada. The jacket remains optional, just as in the UL standard. Sunlight resistance is of course mandatory. There are many optional flame spread markings, along with cold bend and cold impact markings and oil and gas resistance markings. The direct burial marking is only applied to RPVU constructions. Even with the Canadian standard, a wide range of cables are possible. If we look back to our many years of experience, along with our current PV activities with both customers and various other interest groups, we can narrow down the PV cables as follows. For the United States, UL type PV cable is typically rated 2000 volts for use in PV systems most commonly operating at approximately 1500 volts DC. Copper conductors are sized 12 gauge to 8 gauge and are used to interconnect the solar panels or solar modules. Aluminum conductors are sized 4/0 to 1000 kc mil and are used to connect the combiner to the inverter. Crosslink polyethylene insulation is most often used. The conductors are required by most customers to be full colors, red or black, not black with colored stripes. Sunlight resistance is mandatory and direct burial markings are demanded. For Canada, CSA type RPVU 90 cable is the most common type, rated 2 kV for use in PV systems, most commonly operating at approximately 1500 volts DC. The same size range as for the UL type PV cable is common for this cable, 12 gauge to 8 gauge for copper and 4/0 to 1000 kc mil for aluminum. Again, most of the time, crosslink polyethylene insulation is used with full colors, no stripes. Sunlight resistance is mandatory, and RPVU 90 cables are also marked for direct burial. In Canada, direct burial cables should also be marked for cold bend and cold impact at -40 degrees Celsius. On the left, you will see a simplified image of a PV system. Item 1 indicates a solar panel or solar module interconnection resulting in strings, which are connected to a combiner box. These circuits are generally short runs, not more than about 100 feet in length, of circuit-sized copper conductors, ranging from 12 gauge to 8 gauge, with the larger conductor sizes being more common. These cables are typically installed in open air, tied to the racking that supports the solar panel or solar module. This makes for a fast and cost-effective installation. Item 2 indicates PV cable from the combiner boxes to the inverter. These circuits are generally longer runs, measuring hundreds of feet in length, of power-sized aluminum conductors, ranging from 4/0 to 1000 kc mil. These cables are typically direct buried with many circuits in a common trench. Native backfill is used to keep the material and labor cost to a minimum. The maximum conductor ampacities for conductors are dictated by the NEC for installations in the United States and by the Canadian Electrical Code for installations in Canada. Both the NEC and the Canadian Electrical Code have made significant efforts to harmonize maximum conductor ampacities so that they are similar or the same, regardless of which country you are in. The NEC has table 310.16 for not more than 3 copper, aluminum, or copper-clad aluminum conductors in a cable, raceway, or direct burial installations. For similar installations in Canada, the Canadian Electrical Code has Table 2 for copper and Table 4 for aluminum, with direct burial installations also covered in Appendix D. For single conductors in free air, the NEC has Table 310.17 for copper, aluminum, or copper-clad aluminum, while the Canadian Electrical Code has Table 1 for copper and Table 3 for aluminum. Typically, 90 degrees Celsius maximum conductor ampacities can be used, but the code user should be aware of the possibility of termination temperature limitations, limiting the maximum conductor operating temperature to 75 degrees Celsius, or even 60 degrees Celsius for that matter. NEC Article 110.14C1 or Canadian Electrical Code Rule 4-006 may apply. As always, the maximum conductor ampacity is up to the authority having jurisdiction or the electrical inspector. The industry-accepted method of determining the electrical integrity of the PV cable installation system in the field is insulation resistance testing. This test is also known as Mager testing. Since this is a test that is performed in the field after the cable has been manufactured and shipped, the conditions during the test can vary quite widely. For this reason, this type of test is a go or no-go type of test. For a 2 kV rated PV cable, the test voltage should be from 1 kV to 2.5 kV DC, with the insulation resistance value stabilizing within a minute. The minimum acceptable insulation resistance value is 100 mega ohms. If the measured insulation resistance value does not meet or exceed this minimum acceptable value, or the value does not stabilize within about 60 seconds, then the condition of the cable and the test environment should be investigated. It should be noted that the minimum insulation resistance values are based on a 1,000-foot length of cable with a conductor insulation temperature of 60 Fahrenheit or 15.6 degrees Celsius. If the length of the cable is longer than 1,000 feet, then the measured insulation resistance will be low. Likewise, if the conductor insulation temperature is higher than 60 Fahrenheit or 15.6 degrees Celsius, then the measured insulation resistance will be low. Other factors that affect the measured insulation resistance include the insulation type, where thermoset insulation systems will generally have a higher measured insulation resistance than the thermoplastic insulation systems. Humidity, where higher relative humidity environments will result in a lower measured insulation resistance. The test voltage applied. The color of the conductor insulation, where red colored conductor insulation will result in a measured insulation resistance among the lowest, while white colored conductor insulation will result in a measured insulation resistance among the highest. And the age of the cable, where the older the cable conductor insulation, the lower the measured insulation resistance. In summary, there are many different cable constructions allowed by UL and CSA standards. There are various temperature ratings, flame spread markings, and voltage ratings. There are also many different insulation and jacket compounds that are allowed by the standards. We looked at the key PV cable construction details for a common PV cable, including 90 degrees Celsius cable, rated 2 kV, no flame spread markings, cross-link polyethylene conductor insulation, and marked for direct burial. We looked at the typical applications for PV cable and where to find applicable maximum conductor ampacities in both the NEC and the Canadian Electrical Code. We finished off by looking at the field testing criteria for PV cables. Are there any questions? Do you ever work with EPCs on recommendation of cables or for EORs?
We have supplied additional information to the engineer of records on different projects. We don't replace the engineer of record. We do supply a good bit of guidance from time to time in selecting of sizes. And if there's any question of application, then we would spend a good bit of energy talking to the engineers in that regard. But typically we, again, do not replace the engineer of record, if that was the question.
Okay. Isaac, is there a standard for sunlight resistance testing?
There is a standard, and it comes back to UL 2556 or CSA C22.2 number 2556, a harmonized standard, and it will indicate the standard test requirements for sunlight resistance. Generally in the US it's 720 hour, in Canada it's 1,000 hour, generally. But yeah, so ultimately the UL standards, UL 4703 and CSA C22.2 number 271 will refer back to those standard tests.
Okay.
Another question here, what is the difference between Megger testing and VLF testing? So VLF, or very low frequency testing, is more designed for shielded insulation systems, so medium voltage power cables rated 5 kV or greater, versus Megger or insulation resistance testing is for designed really for low voltage cables, so unshielded 5 kV or less, that is 2 kV or less in the US. The idea with Megger testing is you're not stressing the insulation system, whereas some medium voltage or shielded power cable testing systems will stress the conductor insulation. So the idea with Megger testing is not to stress at all the conductor insulation.
Isaac, I believe also on shielded control cables, the Megger test is widely used.
Yes, that's correct.
From the shield to the insulation of the adjoining cable.
Yes.
Isaac, you spoke about sunlight resistance. Does that mitigate the need for split loom. So,
For a split loom tubing.
Mhm.
So yeah, that I just noticed that question there as well. So the idea with the sunlight resistance on conductors or cables is that it can be fully exposed to sunlight. So now you could install the cable open to direct sunlight and not have to worry about having to cover that conductor. Split loom tubing, you could apply it over top of conductors, but that's an added process, added cost. And you'd have to make sure that that split loom tubing doesn't weather and doesn't become brittle, crack, and fall off. So ultimately, getting a sunlight resistant conductor is preferred.
okay, I think we have time maybe for one more. What is the meaning of the voltage rating RPV?
That's a good question. So within the Canadian standard, there are two basic different types of conductors. There is RPV, having most commonly the 90°C temperature rating, so RPV 90, as well as RPVU, again, most commonly RPVU 90. It's very much synonymous with, and actually was generated in the standard based on RW90 and RWU90. So knowing that, RW90 could have a 600, 1 kV or 2 kV voltage rating. That's effectively what was taken to produce the RPV90 product. So you can have a 600 volt rated, a 1 kV rated, or a 2 kV rated RPV90 product with different insulation levels for each. With the RPVU90, the RWU90 was used as the basis, with the conductor insulation thickness being more demanding for the direct burial rating or capability, and so it can achieve a 2 kV voltage rating. So with RPVU90, it can be marked 2 kV or 1 kV. There is no 600 volt rating. So it's more a product of the type designations than the type indicating the voltage class.
Okay, all right. There are still a few questions there. We will follow up by emailing and get you answers to those questions. So again, thank you, everybody. Thank you, Isaac. Enjoy the rest of your day.